Okay, so we're going to go through this quickly because this is most of the stuff that we did in class today. We talked about scale factors in a dilation. We talked about the fact that we have an enlargement or a reduction. We talked about what the scale factor is and how we get it. Okay, we get that by dividing the image number over the pre-image number, depending on what we know about it. Usually it's the side. Remember that everything is similar and in proportion. So if you know one side as a scale factor, that means you know all the sides are the same scale factor. What we didn't really talk about is the concept of where we're going to dilate from. Sometimes we can dilate from the origin, and sometimes we can dilate from a point on the preimage. What does that mean? Well, the point of dilation is either where you're going to dilate something from the middle and expand it out, or you can dilate from one point, expanding it this way. So we're going to talk about that right now by looking at a couple of examples. In this case, we have to know which one is the image and which one is the pre-image. So the blue is a dilation of the red figure. That means the blue is a dilation of the red figure, so the red figure is the pre-image. If you look at the pre-image to the image, you see that this is 6 and this is 2, right? So if we have the pre-image and the image, we have to remember that the scale factor is the ratio of the image to the pre-image. Where does it look like this is shrunk upon? It's actually shrunk at this point, L. If we take this point L and we shrink this big guy down, it's going to always be surrounded around L. And so we have this information. I'm going to move on to the next question. The next question shows us something that looks like this. Well, it's clear that the center of dilation is at A because they share this point. Still, the pre-image is the red and the image is the blue. So this is now an enlargement. The image is 6 and the pre-image is 4. So the scale factor is 3/2 with the A as the center of dilation. If you need to pause and look at this again, feel free. Now let's look at number 3. The only difference between number 3 and number 1 is that number 1, and I'll show you again, gives you the entire side, where number 3 gives you the pieces. So you kind of have to do the math there. So if we look at number 3, I want you to think about the answer. Pause it for a second before I put up the answer. Try to think about what is the scale factor and what you think the center is. Pause. Okay, you're back. So the scale factor, like we said, is always going to be the image over the pre-image. So the image here is 6. The pre-image is 4. So we have a 3/2 scale factor. And it's pretty clear because if the pre-image is red, the blue is bigger, so that's going to be an enlargement, and we know the enlargement is greater than 1. And R is the center of dilation. So what happens when we have something on a coordinate plane? It's actually a little easier, believe it or not. When we know the scale factor, I'm going to focus this in again, one more time. When we know the scale factor, we can figure out how we're going to dilate. Well, again, if the pre-image is red and the image is blue, that means we have a reduction. And we have a reduction of 1/2 because it's 2/4. So our dilation is a reduction of 1/2. Now what we can see here is that the origin is going to be the point of dilation. And this is what it means. If we take a point on the pre-image and we take a point on the image, we can see that if the image is 6, the pre-image is 6, and the image is 3, then we have a 1/2 scale ratio. The image is 4, the pre-image is 2, so we have a 1/2 scale ratio. So let's look about, well, if you had a point on a coordinate plane, how could you use the ratio to get the next point? Well, if I know that this point here is 6, 8, 6, 8, and I know that my scale factor is 1/2, then I know that my image coming from this pre-image is going to be 1/2 of 6, which is 4, and 1/2 of, which is 3, and 1/2 of 8, which is 4. So if I look for 3, 4 on the graph, it should be part of my image. So that looks pretty more doable than just saying, oh, well, it looks this way, so it must be this way. So the next one I want to talk about is this guy. As long as it's on the center, I can identify my points, use my scale factor of 3 to find where the image would be. So if I know that my P is at 2, -1, and I have a scale factor of 3, what is my image going to be? 6, -3. And so that's going to be my P prime, and that's where I'm going to start graphing. So pause this right now and see if you can graph this image, the image of this pre-image with a scale factor of 3. See if you can graph that. So pause this now, and here's the answer. So I went a little bit off my graph paper, and because this isn't a really smart graph. If I knew what I was graphing, which I did, I could have made a smarter graph, and I think you all know that. So, but what I did is I took my points of my pre-image, I did my scale factor of 3 for each of the points, so multiply by 3, multiply by 3, multiply by 3, and now I can graph my image. And so P prime, R prime, Q prime is a dilation of scale factor 3 at center 0, 0, which is the origin. And this is the method that we set up if we have an origin. So if you have a question, just go back. What's the difference between the center at the origin and the center at a point on the image and the pre-image? Think about that. The last thing I want to do is just sum this up. So when we dilate from a point on the pre-image, we simply do the math using the scale factor, keeping the image centered on the given point. When we dilate from the origin, we can follow the point rule. If A equals the scale factor, then our pre-image is going to be xy, and our image is going to be A times x, A times y. Think about this and try some of the homework in your textbook. Bye, folks.